So the last piece of the puzzle here we're going to cover in the context of this slide set at least is our StreamOfFuturesCollector. And we're going to use this to wrap the allOf arbitrary-arity method so it works with the Java streams framework. We've already seen how we use this. Now we're going to talk about how we implement it. So this is actually very similar to other examples we've talked about before. We talked about Futures Collector where we had a list. This is a StreamOfFuturesCollector, and it wraps allOf to work with the Java streams framework. StreamOfFuturesCollector basically is a collector that will convert a stream of completable futures to items of type T into a single completable future that will be triggered when all the completable futures in the stream finish running after their asynchronous processing completes. And it implements the Java collector interface. So as we've seen before when we talked about this in a different context, this implements the collector interface and accumulates input stream elements into a so-called mutable result container. And as you'll see, it's very powerful and it shields you from a lot of nasty code. Here's how this works. So StreamOfFuturesCollector implements collector. It's a generic class. It works on a stream of completable futures of type T, which is a generic type. Its mutable result container is a list of completable futures of type T, and its finisher method will return a completable future to a stream of T. And that's a little different from what we had talked about earlier. The earlier collectors we've talked about have either returned a completable future to a list of T, or we talked about the futures collector int stream, which returns a completable future to an int stream. So this is a stream of T as opposed to an int stream. So again, this just differs from our futures collector because it returns a stream, not a list. Many of the parts are identical. So supplier is going to make a new array list by using the array list constructor reference syntax, which returns a list of completable futures to T when it's called by the Java Streams framework. The accumulator will just add the next item in the stream to the list that is being used. This is only ever called in a single thread, so there's no need to have any locks. This is a non-concurrent collector. Here's the combiner, which could be used if we were using parallel streams. We're not using parallel streams in this case, but we need to do this anyway, just in case we would use parallel streams. And that just returns a binary operator that merges two partial array list results into a single array list. And then here's the finisher. This is the one that does the cool stuff. Remember, finisher is the factory method that's used by the Java Streams Collector framework to transform the array list, which is the mutable result container, into the final completable future result type, which in this case, as you can see, is completable future to stream of T. And here's how it works. Internal to the framework is the futures mutable result container, which is an array list, as we saw, because that's what was created by this. And we then take that list, turn it into an array, pass the contents of that array to the allOf arbitrary-arity method, which, as you recall, is going to return us a single completable future that will complete when all the asynchronous processing is done that we passed in here. So remember, this is all the stuff that's downloading and filtering and storing, all those things. So that's all the contents of this array. And then after all that processing is done, the then apply completion stage method is called on the single completable future. And then this computation gets run. And what we do here is we convert the list of completable futures into a stream of completable futures. That's the same list that we had up here. And then we use map to convert the stream of completable futures to items of type T, objects of type T, to a stream of objects of type T. And we do that by using the join method. And if you recall, join is one of those basic methods that will convert a completable future to T. Now, normally join blocks. Remember, we just talked about how join blocks and you didn't want to call it very much. In this particular case, join will not block. It'll just do the type transformation to from completable future of T to T. And that's because we wouldn't get to this point. We wouldn't get to then apply. We wouldn't get to futures.stream.map unless all the completable futures had finished running asynchronously. So join will never actually block. So we're violating our rule of don't call join more than once, but that's okay because join isn't blocking in this circumstance anyway. So what we end up with here is a completable future to a stream of objects of type T, which is exactly what we want. So that's the super coolness of our stream of futures collector. So just a couple things to remember here. We're using sequential streams here because parallel streams are overkill. We are using this finisher in order to be able to basically have a way to wait for all the asynchronous operations to be done and then convert the result into a completable future to a stream of T. And you can see here, that's exactly what happens. Collect returns that one and only completable future, which will trigger only after everything else is done, and it will then return a stream of T, and then that will be applied after everything is finished, and that's where we do the flat map optional stuff we talked about before to get the actual results. Another little quick note here, we have a characteristics method that will return the characteristics that matter. In this case, it's unordered. And we have the toFuture class, which will create a new stream of futures collector. Okay, so that's the end of the discussion of stream of futures collector. Once again, this is like the third time we've looked at some variation of this, but it's a really important idiom to understand. And if you ever are in a situation where you have to combine Java sequential streams with Java completable futures, these types of futures collectors will be tremendously helpful for you because they simplify the code enormously. And very few people actually understand how this works. So they certainly don't understand the details that we've walked through, but it's good to know how it all works. And it's a great example of how you can take existing piece parts of these functional libraries and combine them together to great effect at a new level of abstraction that's very valuable.